When we collect data, we often look at the shape of the data to tell us things about the data. And so you're going to graph the data maybe on a histogram, which is like a bar chart or a dot plot, and then you're going to look at the shape of that data. Now, remember when we use a histogram or a bar chart, basically the height of the bar tells us how many people answered that question with that answer. So if I ask people how many hours do you study, and 25 of them answered that they study 30 hours a week, and 2 people answer that they study 0 hours a week, then it's going to look something like this, right? I'm going to have tons of people over here and not very many people over here. So there are 3 options when it comes to the shape of data. Your data distribution is either going to be skewed left, symmetric, or skewed right. Those are your 3 choices. So skewed left, it looks like a symmetric curve, right? It looks just like this symmetric curve. But what it looks like is that I took this left tail and I stretched it way out, right? So I pulled, there's a little extra data on this side, on the left, than there is on the right. In fact, the left is more spread out. That's why it's called skewed left. And skewed right's the same thing. I take a symmetric curve, and instead of having the same amount of data on this side and this side, I have more data over here that just spreads out. It just spreads all the way out. So it's like I took it and I just like spread it way out, right? So maybe I have a huge outlier on the right, and that's what it causes it to skew right. So I want you right now just to take a look at what happens to the mean, median, and mode for each of these instances. Notice the mode is going to be the tallest one because it's always the middle. And notice for the symmetric, the mean, median, and mode are all in the same spot. But for skewed left, our median and our mean get pulled to the left, and for skewed right, our mean and median get pulled to the right. I want you to notice that the mean gets pulled way further over than the median does, because the mean is much more affected by a skew than a median is. So anytime we have skewed data, our mean is going to be pulled way over toward wherever that skewed data is, which may affect whether or not we can use the mean as a good indication of center.